2022 AB Calculus, number 1. This is calculator active. Good luck trying this one without a calculator. From 5 a.m. to 10 a.m., the rate at which vehicles arrive at a certain toll plaza. Pause. This is a rate, okay? Good to know. If you take the integral of a rate, you get a quantity. If you take the derivative of a rate, you get the rate at which the rate is changing. Good to know. All right. T is the number of hours after 5 a.m., and A of T is measured in vehicles per hour. Told you it was a rate. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Also good to know. All right. Right, but do not evaluate an integral expression that gives the total number of vehicles. If you take the integral of a rate, you get a quantity. Right? Let's do it. Total number of vehicles that arrive at the toll plaza from 6 a.m., time is equal to 1, to 10 a.m., time is equal to 5. Because remember, this starts at 5 a.m., so 6 a.m. would be 1 hour later. And that would be the integral from 1 hour to 5 hours of A of T dt. It's that easy. You don't have to do anything else. That is all that is required for you to do. And you got 1 point just for doing that. That was part A. That took no time at all. Is that right? We'll use that time elsewhere. Find the average value of the rate. Average value of a function, even if it is a rate, would be this little guy right here. Let's use a piece of paper for that. 1 over b minus a, integral from a to b, f of x dx. So this would tell you the integral of it, which would give you the area on that interval from A to B, and then if you divide by the width of the interval, then it will tell you the average value. Okay, so here goes. Find the average value of the rate in vehicles per hour, which the vehicles arrive at the toll plaza, from time equals 1 to time equals 5. So really the same thing you just did, only we're going to divide by 4 or multiply by 1/4. We'll do that just for fun. And this is something we do need to evaluate. So this is where we need a calculator, and I am going to, whoops, action is stopped, there we go. I'm gonna go in function mode because I'm not, and I should be, clear some stuff out. And we will put this function in, make sure you're in radians, and I am. 450 square root of sine 0.62x, and make sure you're correct. Yep, we're good, all right. 1/4, that takes care of that. Math none, from 1 to 5, A of T dt. We're using x instead. And we need to find the average value of the rate, vehicles per hour. This is going to be vehicles per hour. So 375, always round to 3 decimal places, 0.537. They'll also take 536, by the way. Vehicles per hour. They didn't ask you to write units, but always a good practice to do so. And let's go ahead and grade it. You're going to get a point for the setup. So you got a point here, and you got a point for the actual answer. Part C. Here goes. Is the rate at which vehicles arrive at the toll plaza at 6 a.m. T equals 1 increasing or decreasing? Is the rate increasing or decreasing? Well, this is the rate. We need the derivative of the rate, and then give a reason for your answer. So here's what we're going to do. We're going to find a prime of 1 and crank out an answer, and then we'll know if it's positive or negative, and therefore we'll be able to talk about whether it's increasing or decreasing, and that will be the reason for our answer, which we will articulate. So math number 8 in deriv. We want the derivative with respect to time technically, but in the calculator it's listed as x. Alpha, trace, pull up y1, and we want this at 1, there we go, and it is 148.94, and that is good to know, but I really don't care what that is. 148.947. Here's what I care about. Boom. Let's put it as a sentence. Why? Because they said give a reason for your answer. And I better talk about how it's increasing. And I say it, don't say it in your explanation, right? Let's be very clear and specific, explicit about what we're saying. So the rate at which vehicles arrive at t equals 1 is increasing. Why? Because the value of the derivative at 1 is positive. There we go. Let's grade this one. That's worth 2 points. the next one's where we're going to get most of our points. We're going to have to, or we're going to get a point for just simply doing that. And then we're going to get a point for our explanation, which there are some more specifics about what they're looking for, but it should say increasing, and you should talk about that being positive. All right. Oh, by the way, we do need that as well. Okay, here we go. Now the one that's going to take a lot of our time. So we're 5 minutes in. We've got some good progress going. We might think this is an easy one. We get to part D and things get a little bit tricky. And this entire problem may not take the full 15 minutes, so we can spend it elsewhere. Okay, a line forms whenever A of t is greater than or equal to 400. Let's think about what that means. When the rate of cars per hour, is greater than or equal to 400, then basically traffic starts getting backed up. So there's a toll booth, here's your toll booth, and then the cars keep going by, and they're going by, and there's a rate for this, and it's this function right here. It's modeled by that. And so they go by. But as soon as this rate reaches 400 vehicles per hour, then things get a little bit bottlenecked, and there's a line waiting to get through this toll booth, right? Number of vehicles in line at time t for A to t to 4. Whoa, what's A? Hold that thought, just keep reading. Is given by n of t equals the integral from a to t, a of x minus 400 dx, where a is the time when the, whoa, already a little bit overwhelmed here, okay? Don't be. We are taking the integral of a of t, and then we're going to subtract 400, excuse me. Because getting the integral of a rate is going to give me the quantity. Keep that in mind. That minus 400 is handy too. A is the time when the line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval from A to 4. Justify your answer. Okay, what in the world is going on here? Here's the deal. We don't know when the line begins to form. The number of vehicles in line at time t from A to 4 is given by this function, okay? We don't know when the line begins to form. We know the rate at which the line begins to form, but we don't know when the line. Let's start there, and then we'll interpret it from here. So there's our function. I'm also going to graph the line 400, and we're going to go from somewhere to 4. Let's go from 0 to 4. That's a really good idea. So window from 0 to 4. Okay, what I'm going to do is rely on the calculator to graph this and graph it in a way that it will adjust automatically what I need to see. So zoom, once you have your x's set from 0 to 4, zoom 0. Go ahead and press 0 if you want to, but it's zoom fit. And we are going to see the rate. This is A of t, graphed for us here. And this is the line 400. That x value, technically a t value, is A. Okay? So let's find out what that is. Second, in calc, we're going to get a point of intersection. First curve, enter. Second curve, enter. Guess we're close to where we want, so enter. There we go. And that is 1.469. Now, I like 1.469, and I'm happy with 1.469, but I'm going to store that in my calculator so I don't just get 1.469. I get 1.4693716, okay? So I'm going to quit. That 1.469 was the very last x value I had. We're going to store it as A. It will be capital A for us on the calculator. It's lowercase a on paper. Okay, let's jump back into part D. Here's the deal. I know what A is. It's 1.469. I'm going to write a whole bunch of them just because I find it necessary, and that's the way my calculator has it. Now let's see what we're really dealing with. Let's make sure we understand. To the nearest whole number, find the greatest number, pause. I say that a lot, pause. And then a dog sticks his hand up and pause. Yeah, get it? Okay, bad joke. Moving on. Greatest number, that's a maximum. Maximums and minimums occur where the derivative equals 0. The derivative of what? Okay, I want the greatest number of vehicles, and the number of vehicles is n, okay? I will have the most vehicles in line where this derivative equals 0. Let's keep driving here. if n of t equals, this is a tricky problem, I'm telling you, the integral, by the way, we've already earned 5 points. Those were relatively easy. So don't beat yourself up if this one's a little tricky. A of t minus 400. Now we already know what lowercase a is. That's what we're dealing with. And I need to know where n of t's derivative equals 0. That's going to tell me maximums and minimums. That is going to be very, very handy. So we're going to take the derivative of an integral, which is basically, wait, I need to fix something. A little bit of white out here. Sorry, my fault. This is going to be a of x. There, that's a little better. We're going to take the derivative. A is a constant. We already know what it is. The derivative of an integral just ends up being, in this case, a of t minus 400. That is equal to 0. So that means that a of t equals 0. Oops, sorry, equals 400, my fault. And then t is equal to, okay, well, we already know this one, 1.469, call it lowercase a, this is a. And we also need to know the other one, okay? Well, let's find out what that is. Now, the scoring guideline calls it b. Let's find another point of intersection. This is the lowercase a. This is the other one that, again, the scoring guideline calls a lowercase b. First curve, enter. Second curve, enter. When you're going to guess, get closer to it. And we're closer. There we go. So here's the other one. Other one what? Other point of intersection that is solving this derivative, because I will find maximums and minimums there, right? Okay. That is at 3.5977133, okay? Use more decimals on that if you like, which we did up here. Scoring guidelines calls it b. I'm never going to write b on my paper for this problem unless I find it absolutely necessary, but we know this. So, again, maximums and minimums on the interval from 1.469 to 4 are going to occur where the derivative equals 0 and at the endpoints of the interval, so 1.469 and at 4. So let's test them out. T, n of t. Glad this is calculator active. All right, 1.469. You can call it a if you like. 1.469371591. There we go. If I found the value of the function at a, then I would be going from a to a. You can see where this is going already. A of x minus 400 and then dx. That's just 0. We already knew that. Okay? When the line begins to form at the instantaneous moment, there it is, when the line begins to form, we have 0 cars in it. Now, I've written it in all its decimal glory a couple times, and then I abbreviated it here. I probably should be more consistent, but we're good. We're good. We got the main idea. All right, 3.5977133, round that off if you like. My calculator has it stored as x currently. I'm going to store that as b, and we're going to find n of b, which will be, whoops, I said I'd never use b. Feel free to if you want to. But I'm going to call it 3.5977133 equals. All right, don't even want to write all this right now. So let's just do it. Math 9 from a to b of a of x minus 400, and then there's that. And we're going to have 71.254. Now, technically, that's the number of cars, but we'll be okay with that. And then we also need to check the endpoint of the interval. So that's going to be n of 4, which is going to be exactly what we just did. Let's pull that last thing up, second and enter. Pulls that last one up. We're going to change this to a 4, and that's going to be lower. And we need the greatest number of vehicles. So 62.338 vehicles. They did not tell us to round to the nearest vehicle. It might be logical, but let's not. Oh, they did, the nearest whole number. I'm reading the problem again. To the nearest whole number, find the greatest number of vehicles in line toll plaza. Justify your answer. All right, here we go. Let's see what we're up against. The greatest number of vehicles in line for A to 4 inclusive is 71. Okay, justification. Let's start, let me point out the scoring guidelines a little bit, and we're gonna go from there. So we had to consider that the derivative would equal 0, and we got a point there. And we also found these 2 points. We get a point there. And we get a point for the actual answer. And the justification, I'm going to read through some things here. The justification needs to include this in some way. Like, we're going to have to test the endpoints of the interval. We're going to have to test where the derivative equals 0. And we did not, as far as I can tell, wait. Yeah, as far as I can tell, we did not have to write anything out. Where it says justify your answer, I believe, my understanding, is sometimes your work is justification enough. So the justification is this. Ooh. All right, so there were 4 things they were looking for. Derivative equals 0, final answer, that you found these 2 points, and this process right here, which considered the endpoints and where the derivative equaled 0.